12.8. I would recommend that you pause the video here for students to copy down the notes for 12.8 and then resume, and I'll go over the notes. Press enter now. In 12.8, all the problems are supposed to be real world problems that involve quadratics. The best use of math is how it's going to help you in real life. So that's why we incorporate the word problems, so that you can figure out the greatest or least profit, yield, cost, height, distance, etc. If you are going to become a business person, or if you want to think like a business person, what you want to do is you want to minimize how much you spend, and you want to bring in income. That's how you make more money. That's how you make more profit. And that's what these equations are. They are either going to be, since they're quadratics, they're either going to be graphs that look like this or this. Most of the graphs will probably be like this with a negative a value, but they have these maximums. So if you want to maximize things, you're going to want to figure out what will produce the highest point or profit or yield or cost or stuff like that. Or if you're trying to save money, you want to find the minimum. This will produce the minimum cost of something. So every time you go to graph, or not necessarily graph, but as you read these problems that are in 12.8, knowing what is on the domain, what the domain is measuring, this might be time, this might be units, this might be, I'm trying to think of other things that you could input. Boats, how many boats you make, how many gizmos, how many widgets. You have to figure out what is your x-axis measuring versus what is your y-axis measuring. A lot of times you're going to see profit, you'll see cost, yield, and those words mean it's a measurement of this other thing that you have down here. Do not freak out when you see these things, because the equations are going to be kind of funky. It's all tied to what you just did in 12.7. Here's what I mean. If you can figure out this maximum or this minimum, if you know where that is, you can find the best place as a business person to maximize your profit or to minimize your costs. That's the goal. So if I know those things and I know how to find this point, that point, what we just learned, is called the vertex. If you know how to find a vertex, you're going to be fine. The other thing that you might need to do is you might need to find a particular value or a particular solution, meaning, well, how much is the cost when you make this many boats? Or what is the cost when you have this many gizmos? Plug it in. Find out. It'll tell you. Okay? So we plug it in and we simplify. That's one particular solution. The example that I have picked for you is number 4. I think there's only 9 questions or something like that on that worksheet. I can't remember exactly. How many are there? 8. There's only 8 questions, so I only wanted to do one example. This one example pretty much covers what you're going to have in the problem. Here's how it works. If you want to do this on a separate sheet of paper that you're going to do your homework on, number 4 can be your first problem if you would like. A treasure hunting expedition is trying to have a successful mission and to minimize its costs. The costs in thousands of dollars, I'm going to underline that, are given by this function. Ooh, it's in vertex form. Thank goodness. Where X is the number of people involved in the expedition. People. C is cost. it's going to tell you everything you need to know in the question. It tells you what C is measuring. C is measuring the cost. X is measuring the number of people. The number of people and the cost per person. I mean, that's what we're figuring out. Where X is the number of people involved. Part A, what is the cost of an expedition with 3 people? I'm hoping you know how to find the particular solution. You're going to plug it in. Well, what are you plugging in? You're plugging in 3 people. Is that a cost or is that's people, right? Like you put 3 into the equation. All you have to do, 2 times, the cost will be 2 times 3 minus 6 squared plus 17. 3 minus 6, negative 3 squared. 9. 9 times 2, 18. 18 plus 17. Oh, man, I'm doing that all in my head. What is that, 35? Or sometimes, if you want to double check yourself, like I do, check yourself before you wreck yourself, it's 35. And this is the cost in thousands of dollars. The answer for part A, $35,000 for this treasure hunting expedition by plugging that value in. That's our part A. Part B, what about for 7 people? Well, I'm just going to plug in 7 this time. 7 minus 6, 1 squared times 2. 2 times 1 is 2 plus 7 is 19 is what I'm getting. In my head, I'll probably check on my calculator. A lot of times I like to go up here and just change, delete the, put a 6. Yep, got 19 again. And it's in thousands of dollars. This is $19,000. 3 people, it costs $35,000. 7 people, it only costs $19,000. You want to make sure that your costs are low. Why does it cost less with more people? That's a whole nother question. I'm not going to ask that question. But I think about that question a lot. Like, why does it cost more? Maybe because you already rented one van and now you have more people putting money in and the one van is being spread out with more people. Your costs go down. I know if we take one kid to a track meet and there's one kid in the van, that's kind of a lot of money for a van when, you know, a car would be just fine, right? But if you put in 7 kids in the van, your costs are still the same. Just thinking about it like that. Part C, what is the number of people associated with a successful mission and minimizing the cost? We want to find the absolute lowest possible number cost. And what is the number of people associated with the lowest cost? What does that mean? I want to find the minimum value. This has a positive 2a. If I were to graph it, it's going to look something like this. The minimum cost is where the vertex is. And so because I can find the vertex, do you remember doing opposite same? What is the vertex at, by the way? I believe it's at 617. What is this measuring? This is measuring people, because this is your X. This is measuring cost. If you think of your X and your Y in terms of people and cost, what is the number of people associated with that absolute lowest? As a business person, I always want to have 6 people. What is the cost? 17. But remember, the cost is in thousands of dollars, so I have to make sure that I'm multiplying by 1,000. It's what? Not bad. Fill the van. But if you get 2 vans, your costs go up. So that's why there's an optimal number. I know on a rafting trip, you want 8 in the boat. You have 9, now you got to have 2 boats. Now you got to pay for another guide. Costs go back up. Those are the things that business people think about all the time. We'll stop your notes right there.